Guys, let's look at this problem right here. Here's question is asking, in the circuit of figure 5.124, IS1 is equal to IS2, that's equal to 3 times 10 to the power of minus 16 ampere, beta is equal to 100 and VA is equal to infinity. Calculate VB such that Q1 carries a collector current of 1 milliampere, and B part is asking, construct the small signal equivalent circuit. Now let's do the A part. A part is asking us to calculate the VB. Calculate VB. Now first we have given the informations about IS1, IS2, and let's assume IC1 to be, and also collector current also given, that's 1 milliampere. Let's put that one here. IC1 is equal to 1 milliampere, and if I apply KVL here, this is VCC minus IE1 plus IE2 times 500, IE2 times 500 ohm is equal to VBE. Instead of VBE, we can put VT ln of IC2 over IS2. Now let's go ahead and plug all the values and solve them. Here we instead of IE, we can put 1 plus beta over beta IC, because we don't have IE value, but we can write IE in terms of IC. If you write that, this is going to be VCC minus 1 plus beta over beta times IC1 plus IC2 times 500 ohm, that's equal to VT ln of IC2 over IS2. Now here we are going to find out IC2. We know IC1 already, so let's plug all the values. 2.5 voltage, VCC is 2.5 voltage, minus beta is given 100, 1 plus 100 divided by 100, and IC1 is 1 milliampere, 1 milliampere plus IC2 times 500 ohm, 500 ohm, that's equal to VT, that is 26 millivoltage, ln of IC2 is what we are trying to find, divided by IS2. IS2 is 3 times 10 to the power of minus 16 ampere. 3 times 10 to the power of minus 16 ampere. And if we solve for IC2, we will get 2.42 milliampere. This is our IC2 value. Now we have solved for IC2, so we have solved for IC2, and also we can solve for VBE. VBE1 is equal to VT ln of IC1 over IS1. VT is 26 millivoltage, this is a constant value, ln of IC1 is 1 milliampere divided by IS1, that is 3 times 10 to the power of minus 16, 3 times 10 to the power of minus 16 ampere. That gives us 749.7 millivoltage. Okay, let's get rid of these parts. And continue here. Now here the A part is asking for the VB voltage. Again we are going to apply KVL here in terms of VB. VB minus IE1 plus IE2 times 500 ohm is equal to VBE1. Okay, now IE1, IE2 we don't know, but we can write that one in terms of IC1 and IC2 by replacing this one with 1 plus beta over beta times IC1 plus IC2. So VB minus 1 plus beta over beta times IC1 plus IC2 times 500 is equal to VBE1, and here let's go ahead and plug all the values. VB minus 1 plus 100 divided by 100 times IC1 is 1 milliampere. 1 milliampere plus IC2 is equal to 2.42 milliampere. 42 milliampere times 500 ohm is equivalent to VB1, that is 749.7 millivoltage. And here if you solve for VB, that gives us 2.48 voltage. Okay, now we have solved for VB. Now the next thing is the second part is asking for the construct the small signal equivalent circuit. Let's go ahead and do that. Let's get rid of these parts. So whenever they ask for small signal equivalent, it's always we had to solve the transconductance of the circuit. So to those so the transconductance GM1, that's equal to IC1 divided by VT. IC1 is 1 milliampere divided by VT is the constant value, that's 26 millivoltage, and that gives us 38.5 millisiemens. And R51 can be calculated using this formula beta over GM1, and that gives us 100 divided by GM1 is 38.5 millisiemens, that gives us 2.6 kilo ohm. And R52 is equal to beta divided by GM2, 100 divided by GM2. GM2 is, let's calculate GM2 first. GM2 is equivalent to IC2 divided by VT, and we calculated IC2 previously, that is 2.42 milliampere. 2.42 milliampere divided by VT, that is 26 millivoltage, and that gives us 93.1 millisiemens. Now that's the value we are going to put right here, 93.1 millisiemens, and that gives us 1.07 kilo ohm. Now let's go ahead and draw the equivalent circuit model. Okay. This is GM2 V52, GM2 V52, and this one is 500 ohm, and this one is GM1 V51, and here we have 200 ohm, and the voltage across this one is V52, resistance is R52, and this one is R51, and the voltage across here is V51. And this is our equivalent model circuit of the given circuit. Okay, that's how we do this kind of problems. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn electronics too, there are a bunch of videos in my playlist. I hope you guys watch it too. Don't forget to subscribe. See you next time.